Hi students, welcome to my channel. Today in this session we are going to discuss about Heisenberg uncertainty principle. So Heisenberg uncertainty principle. So this principle is applicable for quantum mechanical property. So this is one of the quantum mechanical property. So this is applicable for any microscopic substances. That means generally mechanics is of two types. One is quantum mechanics, other one is classical mechanics. Quantum mechanics deals with the motion of the particles which are invisible to our naked eye. That means which are not visible to our naked eye. Suppose if you take an electron, that electron is not visible to our naked eye. So we can study the properties of those electrons under the heading quantum mechanics. Whereas the classical mechanics deals with the motion of the particles which are visible to our naked eye. That means we study the properties of substances which are visible to our naked eye. That means the motion of a bus or velocity of a vehicle. So the velocity of vehicle can be studied under classical mechanics, whereas the velocity of an electron can be studied under quantum mechanics. So this principle is one of the quantum mechanical principle. So this principle is applicable for quantum mechanical property like electrons, protons, neutrons, like this. So here Heisenberg uncertainty principle. So this principle states it is impossible to determine both position and momentum, the exact position and momentum of an electron. Suppose if you take an electron, so the electron is present around the nucleus in circular path of an atom. So here it is an atom, it consists of central part called nucleus. So here the electron is revolving around the nucleus in the circular path. So here we cannot exactly determine the position of an electron. Here the electron, we cannot identify the exact position of an electron and momentum also. So simultaneously we cannot determine both position and momentum. Suppose if you are supposed to determine the position of an electron, so we can't determine the momentum of electron, because so this electron is always revolving around the nucleus. So we cannot determine the exact position since the electron is revolving, that is it is moving. Suppose we are supposed to determine the momentum. Momentum means momentum P is equal to mass into velocity. So here mass, you know the mass of an electron 9.1 into 10 power minus 31 kg, that is the mass of an electron. So here we cannot find the velocity of an electron. If you determine the position of an electron, we cannot determine the velocity of an electron since it is moving. So we cannot determine both simultaneously the exact position and momentum of an electron. Okay, so this can be explained by an expression, that is delta x into delta p is greater than or equal to h by 4 pi. So here delta x means uncertainty in determining position of electron, and delta p means uncertainty in determining momentum of electron. So here delta x indicates the uncertainty in determining position of an electron, whereas delta p indicates the uncertainty in determining momentum of an electron. So the product of these two is always greater than or equal to h by 4 pi. Suppose if you take it is equal to h by 4 pi. So let us consider the product delta x into delta p is equal to h by 4 pi. So what it means? The product of two components is equal to constant value. H is a Planck's constant, its value is h is equal to 6.626 into 10 power of minus 34 joules second. So here it is a constant value h, 4 is a constant and pi is nothing but 3.142. So this is both are constant values. So here the resultant value is always constant. So the product of two components is constant. That means if one value is increases, the other value goes on decreases, isn't it? If one value increases, the other value goes on decreases. Suppose if the uncertainty in determining position increases, then the uncertainty in determining momentum decreases. Okay. So here the product of these two components is equal to constant value. Suppose if you are supposed to determine the exact value of position, then the uncertainty goes on increases. That means the certainty of determining momentum goes on decreases. So, if you calculate the exact position of an electron, the momentum of an electron cannot be determined. If you calculate the exact momentum of an electron, the position of an electron cannot be determined. So, that is the product of these two always constant, that is greater than or equal to h by 4 pi. Okay, clear? So, this is about Heisenberg uncertainty principle. So, what is the principle? It is impossible to determine both position and momentum of an electron simultaneously and exactly. So, the exact value of both position and momentum of a microscopic property, here the property of microscopic property, this is an electron. So, micro means very small value, that is 10 power minus 6, micro means 10 power minus 6. So, it is impossible to determine the exact value of position and momentum of a microscopic property simultaneously. So, that is about Heisenberg uncertainty principle. Thank you. Like the session, share the session and subscribe to my channel. Thank you.